Hello, I'm Brandon, and I'm the General Team Lead for the 2023 Formula SAE team for Waikato.
And I'm James, Technical Leader for the Internal Combustion Engine subgroup.
Founded in 2006, WESMO is the University of Waikato's Formula SAE team, taking out the 2022 Australasian competition.
Teams are judged in a series of both static and dynamic events. These are intended to measure students' design ability and understanding. We're also marked on the performance of the car on the track. FSAE teams design, build and race a fully custom car each year. This year, the team is focused on building a reliable car that the drivers can push to the limit with no surprises.
Outside of my role as a general team lead for WESMO, I will be designing and manufacturing the steering system for the 2023 ICE car.
WESMO's steering system has been one of the weaker sections of the car in the past, with drivers regularly complaining about the physical fatigue of driving the car. Because of this, my primary objective is to design a steering system that reduces steering effort as much as possible. The main sections of the car are that of the steering geometry, steering redirection and actuation systems. Each of these factors have a range of sub-factors that have a monumental impact on the steering performance of the car. So far, I have identified and chosen specific concepts for the individual elements that require design, such as the tie rod attachment position, steering rack, steering sensor, and the mounting brackets, having run calculations on a number of these elements for design. The goal for the future of this project is to finish and build a steering system that fits alongside all other components of the car, as well as achieving the cornering and general performance requirements for the competition, while using software and physical testing on the 2018 and 22 cars to identify an optimal steering geometry.
Alongside my responsibilities as the 2023 ICE team's technical lead, I'll be developing the car's suspension actuation geometry and the mechanical components that go along with it.
My challenge is to balance the demands of performance with those of reliability in line with the team's overall goals. My research focuses on the accuracy of our theoretical force calculations to improve our confidence in future designs. I will place strain gauges on the suspension arms of our FSAE car and record the real stress and strain in the suspension members for defined loading conditions. I have produced a MATLAB model of our car. The model takes fundamental vehicle specifications and calculates the suspension geometry automatically. With it, we can calculate the forces in each suspension member for a given dynamic loading scenario. These forces are critical for both design and research. I am partway through producing a detailed CAD model of the new suspension system. This includes brackets, adapters, OEM components, tubing for the front and rear wishbones, push rods, bell cranks, shocks, and anti-roll bars.
Hi, my name is Aidan and I'm developing the uprights and unsprung assemblies for the car. This includes the brakes, wheels and uprights. As for my research topic, this is to develop a topologically optimized upright, optimized for strength and stiffness while minimizing the part mass. This is going to be using generative methods and focusing on using answers to develop the part model. Where this project differs from other topological parts is to develop the design process and design for manufacture with a CNC mill rather than the typical additive manufacturing process. So far, progress has been spent working with the suspension and steering teams to finalize the geometry and the key loading paths which will form the basis of the topological optimization. CAD models of the front have been developed in preparation for FEA and the optimizations. From here, the plan is to finish the CAD models and begin FEA and topological optimization, then manually go over the optimized result to tweak the geometry for CNC manufacture, then FEA to make sure there's no significant changes. This is all to do before mid-June, which is our design freeze.
My name is Daniel and my project for WESMO 2023 involves the development of the drivetrain. My research topic involves assessing the feasibility of a frictionally retained differential to allow for chain tensioning. In the project thus far, calculations have been done to determine how much force the drivetrain will need to be designed for. This includes forces that the engine to differential bracket will have to endure at peak acceleration, and suitable bearings to be used in the mounts. Current CAD drawings depict the drivetrain dimensions relative to each other, such as the engine and sprockets. Brackets between the engine and the rear driveline are currently being developed in CAD, later to be optimised for stress and weight. The plan from here onwards is to finish the design of the drivetrain brackets and have engine mounting locations within the chassis by mid-June for the team's design freeze.
Hi, my name is Ricko Agluba, and I'll be working on the air intake for the 2023 car. My project goals are to improve throttle response by maximizing airflow through the intake system's design, and to tune the engine to maximize performance for the different events, as well as keeping the intake inside the chassis and away from any surrounding components. My research involves finding the effect of plenum volume on throttle response, and this will be done by making a test bench setup consisting of a vacuum pump attached to a mock-up intake to mimic the car's intake system. CAD models, I've been doing some CAD models as well, very detailed ones on different shapes, but mostly the horn style intake to maximize airflow, and I've been doing some flow simulations on these models as well to have a look at the performance and the velocity and the pressure of the air. And my next steps will be to build this intake system test bench, find the optimal intake volume, rescale the CAD models to this optimal volume, and to check spacing constraints with the chassis and redesign the plenum accordingly.
Kia ora, my name is Zoe, and my goal is to make sure everything comes together with the car chassis. My research involves creating a design that is under 30 kilograms while prioritizing torsional stiffness. Through my literature review, I've determined the optimum torsional rigidity for our car to be between 1500 and 1800 Newton meters per degree. I currently have 3 space frame designs compliant with the updated FSAE rules. FEA analysis will be done on ANSYS to make sure the designs have the required torsional stiffness. I'm also in charge of the ergonomics of the car. I've narrowed my focus on finding the optimum seat angle, gear shifter position, and overall cockpit layout to ensure the driver's comfort, all while complying with the strict competition rules. To do this, I have collected driver feedback from previous years to inform the initial chassis and cockpit designs. The next step is to use an adjustable ergonomic jig with this year's drivers to determine the optimum cockpit layout. Finally, I have been working closely with the EV team to make sure this year's design is suitable for next year's electric car.
The ICE team for 2023 is focused on designing, building and racing one last internal combustion engine car before switching to a fully electric drivetrain for 2024.